Hopefully, you got your head around the single node and are ready to move into the heart of Cassandra, the ring, also known as the Apache Cassandra cluster. Because Apache Cassandra is a clustering system, this is an important concept to understand. You could run Apache Cassandra on a single node, but why would you? If you did that, you'd be missing out on all the cool things that Apache Cassandra can do as a cluster. Why wouldn't you run it on a single node anyway? Well, if you did that, it'd have to be a pretty big machine to run that little node, which means spending more money and buying something to handle that load. What we're talking about here is horizontal scaling. If you're looking at my single node here, for a while, he's handling the load just fine. Reads, writes, everything is dandy. But as the load increases, our poor little node is cracking under the pressure. When this happens, the system falls apart. I'm sure you've been in a situation like this before, and it isn't pretty. So, how does Apache Cassandra handle this situation? Well, we just add more nodes. Easy, huh? If you need more capacity, you just add more. In a cloud environment, the cool thing is that you only need to rent more servers to handle the additional load. So how does this Apache Cassandra cluster work? Let's say that I have data come into the cluster that's supposed to live on a particular node. What is the process there? Well, let's show you an example. Let's say I have a partition 59 with some data attached to it. The cool thing is that you can write that data to any node in the cluster. That node will become the coordinator node. The job of the coordinator node is to send the data to the node that stores that partition, that's responsible for that bit of data. Just an FYI, any node can act as a coordinator in the cluster. But how does it really work? How does the coordinator know what node the data should go to? What happens is that each node is responsible for a range of data. This is called a token range. Knowing what range of data each node owns, the coordinator can send the data to the correct node. The coordinator will get the data from the client, then send the data to the correct node. Then the coordinator will send an acknowledgement back to the client. So, how much data are you going to store in this cluster? A lot, I'm betting. In the previous example, we broke the cluster into a range of 100. That was for demonstration purposes only, so it'd be easy for you to understand. A lot of data would not fit into a range of 100. In actuality, the range goes from -2 to the 63rd all the way around to 2 to the 63rd minus 1. That should be plenty for you to store all the data you could possibly want to store. It's a really, really big number. How are the token values across the ring distributed? This is where the partitioner comes into play. The partitioner determines how you're going to distribute your data across the ring. If this gets messed up, you're going to end up with hotspots in your cluster. The data will be distributed unevenly, and some of your nodes will be overloaded while other nodes are happy as clams. This is bad. Eventually, your nodes will blow up, and everyone will be unhappy. The best course of action here is to use the right partitioner for the job. In this case, Murmur 3 or MD5 will do a nice distribution of data across the ring in a random fashion, but an even distribution. By the way, this is the default. Let's talk about when a node joins a cluster. This is a really cool thing when it comes to cluster operations. What makes it cool? No downtime. The cluster stays up and running while a new node joins. So what actually happens when that node joins the ring? Well, first thing it does is it gossips out to the seed nodes. Just a little shout out to say, hey, I'm new here. What do I need to know? The other nodes calculate where it fits in the ring. This can be manual or automatic. And then the other nodes stream their data down to the new node. There are 4 states to each node: joining, leaving, up, and down. During the joining phase, the node is still receiving data, but is not fully joined, so is not ready for reads. But what's neat is this node is joining online. There's no downtime here. Now, if you have all this data flying around your cluster, your drivers can really come in handy. When a driver connects to an Apache Cassandra cluster, it participates in the exchange of all this data. When the driver connects, it's going to get a lay of the land and an understanding of the token ranges and will store that information locally. The driver is then aware of what token ranges belong to which node and which replicas. So why is it important for the client to know what's going on in the cluster when it comes to token ranges? Well, the cool thing about the driver is that it is aware of the token ranges. One of the driver's policies is called token aware policy. That's cool. So when data comes into the driver says, oh, this node owns this token range, so I'm going to send the data directly to the node. What's cool about this is that it eliminates the need to involve the coordinator, thus making the system more efficient. There are other policies as well, such as round robin. that do rely on coordination, as well as the DC-aware round-robin policy, which makes sure the data stays within the local data center. Apache Cassandra is topology-aware, so your drivers should be as well. What does this all mean with scaling? Well, back to our single server environment. The single server can get overloaded, which is bad, all the way around. At this point, you have a choice. You could get bigger and better servers, which means you're going to have downtime as you offload data and move everything to the bigger server, or you could go back to what Apache Cassandra does best. You can add more nodes as the load grows. Let's take a look at this graph. As you add more nodes, you get more capacity. This is a read-write-modify load. The same holds true for the read-mostly load or the read-write balance load. Any of these should show that just by adding nodes to the cluster, all of these behave about the same way when it comes to scaling with Apache Cassandra. To sum up, you add more nodes, you get more capacity, which rocks. Being able to add more capacity online? No downtime? Wow! We are always talking about horizontal versus vertical scaling, but it's still important. Vertical scaling is still a thing. You can beef up the servers you have to add capacity. That'll work. However, horizontal scaling is key here. You always want efficiency, right? You can see here that 2 nodes can do a lot of work on their own. But if you double that, you get twice the capacity, and so on, and so on, and so on. Every time you double the number of nodes, you are doubling capacity. Production clusters of 10 or 100 or 1,000 nodes are built to match the load that they are put against. A cool feature of Apache Cassandra is the ability to scale as you need to. That being said, the opposite is true as well. If you had scaled up your cluster in a time of increased workload, for example, Black Friday, you could scale back by decommissioning nodes if they're not needed anymore. This will save you time and money in the long run.